Hello students, welcome to our YouTube channel Experience Tutor. Today we'll discuss class 12 physics get more than 95% marks series. Chapter is alternating current. Chapter 7 NCERT line by line part 1. Students, if you have not subscribed our channel, please subscribe us and please like and share our videos among your friends and relatives so that they can get benefited of it. And please click on the bell icon so that you can get automatic notification whenever a new video is uploaded or whenever a new notification is given by us, so that you should not miss any of the important notification or important video tutorial. Let us begin today's lesson. Introduction 7.1 Introduction. So in this whole paragraph we have underlined the important line which we'll discuss. These currents, first is these currents do not change direction with time. These currents means the DC current. So DC current do not change direction with time. Remember, but AC current varies like a sine function with time. But AC current always changes its direction with time. So AC current varies with like a sine function. What is sine function? Sine curves. It is simple like a curve. So if this is x and y axis, then sine curve will be in this way. This is a sine curve, and it can go furthermore in this way. It happens. AC voltage means alternating voltage. AC current means alternating current. AC voltage can be easily and efficiently converted from one voltage to another by the means of transformer. So the lines which are written here are telling us about the benefit of AC current or AC voltage over DC current or DC voltage. The first benefit is AC voltage can easily be and efficiently converted to one voltage to another by means of transformer. So 120 volt can be converted easily and efficiently to 240 volt by transformer. First benefit is this. Second benefit, for the electric energy can also be transmitted economically over long distances. So the power unit is can be situated long in a long distance, 100 kilometer 200 kilometer far away from the town or city, but AC current supply can be easily and conveniently and economically reach to those cities, towns and villages. So if this is AC current, then therefore it is possible. For DC current it is not possible. And third, most of the appliances which we use on a daily basis are made up of AC circuit, so that they can be used with AC current. So these are the big benefits of AC current or voltage over DC current or voltage. So this is all about introduction. Let us move forward. 7.2 is AC voltage applied to a resistor. Now this whole thing this there is a in the figure if you see there is a AC supply E, this one, and a resistance R is joined in the circuit. We will find out different expressions for this circuit for voltage, power, current, etc. So in NCERT book it is given in a long and quite lengthy way. These all things are given, which which is little complex. So let me explain you in a easy way so that you can understand step by step without any difficulties. So from here just you see this figure, AC voltage applied to a resistor. Rest I'll make you to understand easily and conveniently. After I have explained, you can go through this NCERT solution. You will understand that also. So, so figure 7.1 shows a resistor connected to a source E of AC voltage. The symbol of an AC source in a circuit diagram is given as like this. We consider a source which produces sinusoidally verifying potential difference across the terminal. Let the potential difference, also called AC voltage, is given by. So first equation, V is equal to Vm sine omega t. This is written in equation 7.1, where Vm is the amplitude of oscillating potential difference. So why we have written this? From where this equation came from? Remember, this follows AC current always follows the sine curve and it is in simple harmonic motion, and this equation is also, so this equation is written as simple harmonic motion, where Vm is the amplitude. Vm is the amplitude. Here also you have written Vm is the amplitude of oscillating potential difference, and omega is the angular frequency. Omega is the angular frequency. So any problem why this equation came? This is a simple harmonic motion equation. Why we have written that? Because AC current is said to be a simple harmonic motion. It follows the concept of simple harmonic motion. Fine. Next, to find out the current in the circuit, we apply Kirchoff's law. So what is Kirchoff's law? Law. So in a closed circuit, the total EMF is equal to 0. So we can write EMF as IR, correct? So we can write Vm, we can write instead of V, the potential difference, we can write IR. So we can write IR is equal to Vm sine omega t. Till here any problem? Why we have written IR instead of V? Because we have applied Kirchhoff's law. Sigma E is equal to 0 and E is equal to, we can write IR So V is equal to IR we have written. So we can write again I is equal to Vm by R sine omega t. Again we can write I is equal to Im sine omega t. I is equal to Im sine omega t. This is equation 7.2 in your book. Now where the current amplitude Im is given by. So where current amplitude is equal to Vm by R. This is also called current amplitude. And this is written as equation 7.3 in your book. Then what is 7.3? 7.3 is nothing, just Ohm's law. V is equal to IR, nothing else. Now let us go to your book and see few of the concepts. So for a pure resistor, the voltage and current are in phase, which means the minima, zero and maxima occur in the same time, same respective times. So here you see Im is this. So the black one, the gray one is I and the blue one is V. Blue curve is V. You can see they start at 0, they meet at pi, again they meet at 2 pi. X-axis we have taken as omega t. So here minima, 0 and maxima occur at the same respective times. Therefore, the voltage and current are in phase with each other. Let us move forward. So we see that the applied voltage and current varies sinusoidally and corresponding positive and negative values during each cycle. Thus, the sum of instantaneous current value over a complete cycle is 0 and the average current is also 0. Now, we'll find the power. So, we have a resistor in a circuit. Thus, there is a joule heating and dissipation of electric energy when AC current supplied through a resistor. So, the instantaneous power dissipated in the resistor, we can write P is equal to I square R. And putting the value of I from this previous equation, we can write P is equal to I m sine omega t sine omega t. Instead of I will write sine omega t from here. I am sine omega t r. So P is equal to, we can write I m square sine r sine square omega t. And this is written as 7.4, equation 7.4 in your book. Now, the average value of P over a cycle. So, average value P dash is equal to, we can write mean value for I square R. So, that is equal to mean value of I m square R sine square omega t. This is written as equation 7.5a. Now we can write P mean is equal to I square I m square R sine square omega t mean. That is 7.5b. Now we can write, we know that sine square by trigonometry sine square omega t is equal to half 1 minus cos 2 omega t. Therefore, therefore, so this we know as a formula, trigonometric formula. Therefore, we can write P dash is equal to I m square R. So we can write here mean of sine square omega t is equal to half 1 minus mean of cos 2 omega t, cos 2 omega t mean. Now mean of sine square omega t is equal to half 1 minus cos 2 mean of cos 2 omega t. Now mean of cos 2 omega t means, what does it mean? Just find it out by integration 1 by t cos 2 omega t dt, which is equal to 1 by t 1 by t cos 2 omega t is cos omega, integration is sine 2 omega t, and 2 omega t's integration is 2 omega, and put the limits, that is 0 to t, we get 2 omega t sine 2 pi sine 2 omega t minus 0, and if we solve it, this becomes 0. That means the value of cos 2 omega t, mean cos 2 omega t is 0. Put this value, put this value 0 here. So, or not here, put this value here. So, what we get now? Okay, before putting this value, why we got this value? So we have to find out why. We have to know why cos, mean of cos 2 omega t is this. So there is a integration rule. The average value of function t, say there is a function t, the average value, the mean value of function t, there is a formula for it. That formula is 1 upon t, integration of 0 to t, f function of t dt. Same we have implemented here. Mean of cos 2 omega t is equal to 1 by t, this is 1 by t, this is 1 by t. Integration of 0 to t, integration of 0 to t. Cos 2 omega t dt. So function, whatever the function is here, the function is cos 2 omega t, so cos 2 omega t dt. And just solving the integration, and we get 0. Now we have to put the value of mean cos 2 omega t as 0. We will get mean of sine square omega t is equal to half 1 minus 0. Now therefore we can write mean of, so from where we got this, from here, now we got this value. So mean of sine square omega t is now equal to half. So we can write now equations 7.5b can be written as mean of p, that is power im square r, and instead of mean value of sine square omega t we can write half. So this will be, p mean will be equal to half I square m r. This is 7.5 C. This is 7.5 C. Therefore, to express the AC power same in the same form of DC power, a special value of current is defined and used, which is called root mean square, RMS, root mean square, or effective current, which is denoted by I RMS or simply I. Now let us see the book. So we have derived the equation 7.5c. P mean is equal to half Im square r. This Im square is called root mean square or effective current. Now in the graph we can see the RMS current I is related to the peak current Im by I is equal to Im upon root 2 or is equal to 0.707 Im here. So if this is Im and this is I, then I is equal to Im upon root 2 or 0.707 multiplied by Im. I is equal to 7.7 multiplied by Im. It is defined by I is equal to mean of I square under root mean of I square under root half I square m. So Im upon root 2. I is equal to Im upon root 2. If you divide 1 by 1.414, the value of root 2, you will get 0.707 Im. This is defined as equation 7.6. In terms of I, the average power denoted by P is equal to P mean is equal to half Im square R. So we have already find out this value P in 7.5c. Let us see the equation again. P mean is equal to half Im square R. Now P mean is equal to half Im square R, which can be written as I square R. Similarly, we have defined the RMS voltage and effective voltage by V is equal to Vm by root 2, that is 0.707 Vm. Equation 7.3, we have Vm is equal to IMR, Im multiplied by R, that is Ohm's law in this term. So Vm we can divide by root 2 in both the sides. So Vm by root 2 is equal to Im by root 2 R, and instead of Vm by root 2 we can write V, and effective voltage instead of Im by root 2 we can write I, and this R, so B is equal to IR. Again it is proved by Ohm's law. Ohm's law is again proved. So for a household voltage, that is 220 volt, if we want to find out Vm, then Vm is equal to root 2 into V, and instead of V we'll put 220 volt, and instead of root 2 we'll put the value 1.414, and we get 311 volt instead of Vm, the value of Vm. So in fact, I is the RMS current, is the equivalent DC current what would produce the same voltage power loss as alternating current. Equation 7.7 can also be written as P is equal to V square upon R, or is equal to I into V. So let us do one sum. So example 7.1, a light bulb is rated at 100 watt. 100 watt is the power. For a 220 volt supply, that is the voltage, find A, the resistance of the bulb, B, the peak voltage of the source, and the RMS current through the bulb. So we have given power is equal to 100 watt, V is equal to 220 volt, resistance of the bulb, we know that uh, P is equal to V square by R. So we can write R is equal to V square by P. Putting the value of V and P, we get the answer. The peak voltage of the source is, we know that Vm is equal to root 2 into V. Put the value of V, that is 220, multiply by root 2, that is 311 volt. Since P is equal to IV, so I is equal to P by V. So put the value of P and V, we get I, that is 0.450 ampere. Now next topic, 7.3, representation of AC current and voltage by rotating vectors, phases. So in previous section we learned that the current through a resistance and is in phase with AC voltage. But this is not so in the case of an inductor, a capacitor, or a combination of these circuit elements. In order to show phase relationship between voltage and current in an AC circuit, we use the notion of phasors. The analysis of an AC circuit is facilitated by use of a phasor diagram. A phasor is a vector which rotates about the origin with angular speed omega, as shown in figure 7.4. The vertical component of phasor V and I represent the sinusoidal varying quantity V and I. The magnitude of phasor V and I represent the amplitude or peak value of Vm and Im on these oscillating quantities. Figure 7.4a shows the voltage and current phasors and their relationship at time t1 for the case of an AC source connected to the resistor, that is the corresponding to the circuit shown in figure 7.1. So Im sin omega t1. So this is omega t1, this is I, and this is V. You will get more understanding of this in figure 2. So if the blue one is the voltage curve, then I dotted one is the I curve. Both are moving with a omega t along x-axis. Both are sine curve and moving along x-axis with omega t. Now that is corresponding to the circuit shown in 7.1. The projection of voltage and current phasors on vertical axis, that is Vm sin omega t and Im sin omega t, respectively represents the value of voltage and current at that instant. As they rotate with frequency omega curves in figure 7.4b are generated. From figure 7.4a, we see the phasor V and I for the case of a resistor in the same direction. This is so for all time. This means the phase angle between the voltage and current is 0. So phase angle is, that means they are at the same point. Phase angle between the voltage and current is 0. So this is nothing just in graphical representation of the voltage equation as well as current equation of AC circuit. Now the next topic 7.4, AC voltage applied to an inductor. We'll do topic 7.4, AC voltage applied to an inductor in the next session. Before closing today's session, we request you to subscribe our channel if you have not done yet. Please like and share our videos among your friends and relatives, and please click on the subscribe button to support us if you have not subscribed yet, and also click on the bell icon to get automatic notification whenever a new video is uploaded by us, so that you will not miss any of the important videos. Thank you very much.